Dear friends, in this video, we are going to discuss about the combustion phenomena. Now, in the last few lectures, we already discussed about the different things associated with the SI engines. Now, in this video, we are going to discuss about one of the very important thing in the SI engines, and that is nothing but the combustion phenomena. As we discussed in the earlier videos, the combustion phenomena in the case of SI engines thoroughly. Now, in this video, we are going to talk about the different stages of combustion in the case of SI engine with the help of this particular notes part. So here, the actual stages of combustion in SI engine. So dear friends, this will be the very important question and will be asked in your examination for 6 to 8 marks. Okay, so the question will be like this. So explain different stages of combustion in SI engines. So that time you have to write all these things and you have to draw a stages of combustion diagram which we are going to discuss now. Okay. So basically, these particular stages of combustion invented by Sir Ricardo England, who known as a father of engine research, who describes the combustion process in SI engines as consisting the three stages. So these particular combustion stages in the case of SI engine consisting the three things, or we can say there will be a three stages of combustion in the case of SI engine. So basically, with the help of this particular diagram of the pressure versus crank angle, with the help of this diagram, we are going to discuss the stages of combustion in the case of SI engine. So all the theory part is again present over here. Later on, we'll talk about this also. But here, we are going to discuss the very important thing, and that is nothing but called as the stages of combustion in the case of SI engine. Okay. So with the help of the pressure versus crank angle diagram, we can understand the stages of combustion in the case of SI engine. So let us consider here on the y-axis, here we have the pressure inside the engine cylinder. So during the actual operation of the engine, whatever pressure rise will be there inside the engine cylinder, we will get on the y-axis, and during the actual working of the engine, whatever crank angle in the rotation, or we can say crank angle degree as per the rotation of the crank angle, here we can get on the x-axis. So this diagram is nothing but called as a pressure versus crank angle diagram. So again here we have one specific curve like this. Okay, so as the engine operates as per the combustion process done inside the engine cylinder, we will get the curve like this one only. Okay, and this curve represent the different stages of combustion in the case of SI engine. So on this particular curve, we have the different points, point A, point B, point C, and point D. Okay, so let us consider the point A is a point of ignition. Let us consider point B is a point of combustion. Then point C is the point after this one, or we can say at this particular point, pressure inside the engine cylinder will be the maximum, or it is nothing but the maximum pressure point, we can say. So according to Sir Ricardo, there will be three basic stages of combustion. That is first ignition lag, the second stage is propagation of flame, and the third stage, that is nothing but called as the after burning. So please remember, dear friends, according to Mr. Sir Ricardo, there will be three stages of combustion. First one, A to B is the first stage, and that is nothing but called as the ignition lag. The second stage, that is process in between B to C, that is called propagation of flame, and C to D is nothing but called as after burning. So please remember always A to B is first stage, B to C is the second stage, and C to D is a third stage of a combustion. Okay, so now we are going to discuss about the each and every stage of combustion clearly in detailed manner. Okay, so we start with the point A. Okay, let us assume suction process will happen inside the engine cylinder. Amount of air and fuel mixture comes inside the engine cylinder, and now the position of the piston is at bottom dead center. And now during compression stroke, piston is moving from bottom dead center to top dead center. So during piston moving from bottom dead center to top dead center, whatever air fuel mixture which present inside the engine cylinder, it will get compresses. Okay, I hope you remember the working principle of the SI engine itself. I am just repeating the things. Okay, so during suction, piston moving from TDC to BDC. During compression, the piston movement from bottom dead center to top dead center. And at the end of the compression stroke, the spark plug provides the spark. So let us consider, here is the point and this is the point A where the spark plug provides the spark. Let us consider the process A at the point A. This is the end of the compression stroke, and at the point A, the spark plug provides the spark and ignition taken place inside the engine cylinder. So this point A is represent the point of ignition where spark plug provides the spark. But in actual practice, in actual working of the engine, though the spark plug provides the spark at the point A, ignition taken place, but there will be a no any kind of combustion still taken place. There should be a requirement of some time lag, we can say, or there will be a some time lag, and that time lag is nothing but called as the ignition lag. Okay, so as at the end of compression stroke, spark plug provides the spark, but immediately the mixture will not start to burn. It takes some time to burn. At that time is nothing but called as the ignition lag. So that the process A to B is represent the first stage, that is nothing but called as a ignition lag. So we can say at the end of compression stroke, spark plug provides the spark at point A, but actual combustion will start to take place from point B. Here we can see the point B is nothing but a point of combustion. So the A to B process is nothing but called as the ignition lag. There will be some time lag, we can say. Ignition taken place at point A, but actual burning of air fuel mixture will start to take place from point B or at point B. This point is called as the point of combustion, and point A is called as the point of ignition. So during this particular process, the crank will travel in the theta 1 degree. So here you can see the theta 1 is nothing but the rotation of the crank, and there will be an angle of theta 1, means there will be some movement of the crank angle also. And this first one A to B is nothing but called as the first stage of combustion, that is ignition lag. In simple, we can say the actual ignition start to take place point A, but actual burning will start to take place after some minute period of lag or some minute period of time lag, and the burning will start to take place at point B. So this lag is nothing but called as a ignition lag. So dear friend, this lag will be very very small. It may be 0.002, 0.003 seconds. So a small, very micro lag, micro time lag will be there. But because of this lag, the first stage of combustion will happen, and this is nothing but called as the ignition lag. So hope you understood the first stage of combustion, and during the first stage of combustion, the crank angle rotation in degrees, that is theta 1. Okay. So similarly, now at the point B, the combustion process will start to take place. We know then the power stroke will start to happen. So during power stroke, the burning will be there. Whatever air fuel mixture which present inside the engine cylinder, it will be start to burn immediately, and there will be a very huge temperature, and there will be some increment in the pressure from B to C. If you see over here, the initial pressure is less, then at the point B, somewhat pressure is increases, and at the point C, this is the point where the maximum pressure, because combustion process carried out during the process B to C. So this B to C is nothing but called as the second stage of combustion, propagation of a flame. So what is the meaning of propagation of flame? Here is again interesting one. So as I just said, the actual combustion start to take place at point B, but in between the period of B to C, the flame will move in the forward direction, the combustion flame, as we already discussed in the last video also, the process of combustion. As the flame move forward, the air fuel mixture will come in the contact with that particular hot flame, and the air fuel mixture will burn simultaneously. So during process B to C, very high temperature is present inside the combustion chamber. Whatever fuel mixture is present in that chamber, it will in the contact of that particular hot temperature or that particular thin flame which is coming from the combustion, and because of that burning will taken place during the point B to C, during the process B to C, and during this particular time again crank will rotate theta 2 degrees, and this B to C, as the flame propagates from B to C point, this second stage is nothing but called as the propagation of a flame. Propagate is nothing but that particular flame will move forward direction, that is nothing but called as a propagation of flame. This is the second stage of combustion. Okay. So after the second stage of combustion, the air fuel mixture will burn, we can say almost completely. I am just using the word almost completely, not 100%. And during this particular time, the pressure inside the engine cylinder is maximum, and it will be reached to the maximum pressure point at the point C. And after that one, the next stage of combustion, that is C2D, is nothing but called as the after burning. So in this case, we can say the expansion process is carried out inside the engine cylinder. Piston is moving from TDC to BDC. In this case, during this process, though the high temperature is present inside the engine cylinder, so still if some amount of air fuel mixture remain to burn, that will burn after the point C. That's why the process C2D is nothing but called as a after burning process, and this way the combustion process carried out inside the SI engine. So as we just discussed, in the case of SI engine, there will be a three stages of combustion. First one is the ignition lag. Second one, that is the B2C, propagation of flame. C2D, that is third stage after burning. So the angle of advance, again in the process of the first point, that is ignition point, and in between the point B to C, the angle of advance is again there. This is as per the rotation of the crank angle. So this angle is nothing but called as the angle of advance. So always remember, dear friends, A to B is the first stage, B to C is the second stage, C to D is the third stage. First one is the ignition lag. The lag is because of the point of ignition and the actual point of combustion. That lag is nothing but called the ignition lag. B2C is nothing but the propagation of flame. As the flame will move forward, the air fuel mixture will get burned. That is nothing but called as the propagation of flame. And C2D, whatever air fuel mixture yet remain after the propagation of flame stage, that particular air fuel mixture will get burned during this particular process, C2D, and this is called the afterburning process. Okay, so hope you understood the things clearly with the help of this particular diagram. The first stage ignition lag is again very much small, near about 0.002, 0.003 second. That micro time is there. The second stage, that is again the propagation of flame, which is again present over there, and during afterburning the air fuel mixture will get burned whatever it is remaining. So whatever I am discussing over here, the things are present in the notes part also. The period of ignition lag is very much small and lies between 0.00015 to 0.002 second. So please concentrate on these particular values. This lag is very very small, it is very minute lag in 0.002 second. Okay, this is the part of the second itself. So ignition lag is 0.002 seconds, corresponding to near about 35 degree of crank rotating when the engine is running at the 3000 rpm, and the crank angle required, which is known as the angle of advance, which increases with an increase in the engine speed. So this is all about for the different stages of combustion. Whenever the question will come in your examination, explain the different stages of combustion in SI engine, you have to write all these things in detailed manner, and you have to draw this particular diagram and explain each and every stage in clear manner. Okay. So after this point, the another point which is associated with these stages of combustion, the factors which are affecting the flame speed. Okay, flame speed means what? As we just discussed in this particular diagram, the propagation of flame, even though in the combustion process also, in this diagram we discuss, as the spark plug provides the spark, it leaves behind a thin flame, and this flame will move in the forward direction in the case of the combustion chamber, or in the case of SI engine. So as the flame will move front forward direction, whatever mixture is present inside the engine cylinder, it will get contacted with that hot flame and it will be burned. So this is nothing but called as a flame moving forward direction in the case of SI engine. So similarly, what are the different reasons behind that there will be some flame speed will be affect? Okay, that factors here we are going to discuss. Definitely, if the flame will be moved in normal velocity, then definitely the engine will give a good efficiency. But if the flame speed will not as per the requirement of the engine, definitely it will not good for the engine, and it will be affected on the performance of the engine. So with the help of this one, we will discuss what are the different factors which affect the flame speed. So the first factor which affect the flame speed, that is the air fuel ratio. If we are not able to supply the exact amount of air fuel ratio to the engine cylinder with the help of the carburetor and the associated thing, then definitely there will be a problem on the flame speed itself. So sometime if it is required, lean mixture is required to the engine, but the carburetor supplying the rich mixture, then definitely it will be affect on the flame speed. So the air fuel ratio is one of the important factor which affect the flame speed. The second one, the incorrect compression ratio. So as per the requirement of compression ratio, as per the requirement of the design of the engine, the correct compression ratio is not there. So again it will be affecting on the flame speed. Sometimes flame will move with very high velocity, and sometimes the flame will move very low speed itself. So that will be nothing but called as the affection in the flame speed. So similarly, the third one, the intake temperature and the pressure. This would be again very important factor. Intake temperature and the pressure. As the air fuel mixture enters inside the engine cylinder, that time what should be the pressure of air fuel mixture? Sometimes that pressure is maximum. Sometimes the temperature is also maximum. So it's affect on the flame speed. So the what kind of load which coming on the engine, it is higher load or lower load, it again affects on the flame speed, then the turbulence, and again the engine speed and engine size. So these all are the factors which affect on the flame speed which required inside the engine cylinder. So, with the help of this, dear friends, we discussed the few things. We understood the different factors which affect the flame speed, as well as we discuss about the different stages of combustion in the case of SI engine. So, thank you so much for watching this particular session on the SI engine. So, thanks a lot, dear friends.